Okay, here we go. I'm trying to explain what is deep neural network and the intuition behind it. Okay, so the neural deep learning basically is a branch from, if you look at the artificial intelligence space. So this is the artificial intelligence, right? And then inside the artificial intelligence, there's a machine learning. And right over here, ML, right? And inside the machine learning, there's a deep learning, right? So when you look at it, deep learning is a subset of machine learning, and machine learning is a subset of artificial intelligence, right? So artificial intelligence is basically trying to mimic human intelligence artificially. That's what basically it is. It's just trying to make machine basically smarter, just like to be able to think. I think that's the key word. Machine to think. So that's what artificial intelligence is. So you can think of it like the example of the computer chess that I think IBM made it versus Garry Kasparov, yeah, in I think 1980s, right? So that's like one form of artificial intelligence, and machine learning is a subset of artificial intelligence, with basically so in the software space, right? I don't know if you heard there's a traditional software, yeah, traditional, which is traditional. Basically you make a lot of rules, right? If then else, right? So you have an objective over here, right? And then you make an if then else statement. You define the rules, how to accomplish that objective, right? So this is traditional software programming. So the human will do this, right? Human will do this, but in the machine learning, so the example of the one I just mentioned, the chess computer, the one that's beat, I think, Garry Kasparov, right? And that's a form of artificial intelligence, but it's also, categorically speaking, it's under the traditional software, because the computer was being designed by human, or the rules, right? The rules are being written by human, right? So the if then else statement. Machine learning is a totally different paradigm. Instead of the rules by human, the rules is written by machine. That's why it's called machine learning, right? The one that's learning is the machine instead of the human. So you can say that the software traditional programming is called human learning, yeah, instead of machine learning, if you want to draw that analogy, right? But this is basically the big difference, right? From human, the traditional classical programming, to machine, the one who's making the rules. So what is the role of the human here, right? What's the human role? Is more like acting like a teacher, as a teacher, right? So instead of over here, the role of the human basically writing all the rules, right? But over here, acting as a teacher, so it will provide input, and in this case, I will just make it in a specific machine learning. It will provide an output too. So input and output. So it will provide some data, in this case, and it will provide a label, right? Right. So I don't know if you can see. And in between this is a box. It's kind of like a black box, they call it, but actually it's not really a black box. Yeah. Later we can go back into this to clarify why people call it black box because it's written again by the machine instead of by human. So you cannot actually like literally open up this machine and then look at what are the rules. You can, in a way, you can look it up, but it's not like it's not written by literally like if then else statement, but more like a parameters, right? More like a numbers, more like a function. This is like a function of x, which is, you know, could be like, yeah, more like a function instead of the if then else. But in a way, the machine is the one who's doing all of the analogy of it is doing all of the if then else statements in a form of a function, of a mathematical function, right? So that's basically it. And if you go deeper, or you go inside a subset of machine learning, there's so in the machine learning area, right? There are so many algorithms, and we call this a learning algorithm. Yeah, a learning algorithm. So remember, in a machine learning, the paradigm changed. The machine is the one who is writing the rules. The human here is just providing the data, and sometimes also the label. I said sometimes because it's not all the time. And then this is where the machine is, right? Writing the function. Right? And to write the function, the machine needs an algorithm. It's called a learning algorithm, or it's also called a classifier. In the case of if the objective of this machine learning is to classify something, like say a dog or not a dog, right? To classify or to classify one or not one. Very simple stuff, right? So we have so many algorithms. There's like a support factor machine, there's a nearest neighbor, something like that. There's a I think KNN call it, and then there's a random forest, there is a XGBoost, right? But in the last, since 2012, I think the last 5 years or 6 years, there is a algorithm called one of the algorithm called deep learning, yeah, or deep neural network, yeah. And this algorithm basically is so successful. It beats all of the algorithm in terms of the accuracy, or the error rate is very low, right? So the error rate is really low, or the accuracy is really high compared to all of these algorithms, right? But the downside, and this is the traditional belief, and some of the people is trying to like dispute this. The downside is it needs a lot of data to do that, yeah. So this is what where the deep learning is, right? So this is what we're trying to do, and the reason why we are doing that, because deep learning is like one of the most powerful algorithm there is, right? First of all, it's changing the paradigm. It's the machine who's doing the learning, right? Secondly, the accuracy is really high. Really high, right? Or the error rate is really low, right? And so that's why now many of the areas of research are dedicated into this area, the deep learning. And deep learning is basically drawing the inspiration from how the brain works. And how the brain works is basically our brains contains of millions of neurons, right? Millions of neurons. And all of those neurons are interconnected with billions of synapses, right? Billions interconnected. Right? So this is the basis of the why they also call it a neural network, right? It's basically drawing the inspiration from how the brain works, right? And there's millions of neurons inside our brain, and each of those neurons are they're connected to every neurons in our brain, and those connections could be in the billions, right? So this is the basis of that, and in the next video we will discuss more in detail about that.